Hello everyone. In this class I am going to explain about components of a general purpose image processing system. This concept explains what are different components needed to process an image. These are the components required to process an image. See, this is the problem domain. Problem domain means the image that you're going to process. What processing technique you have to apply. That becomes your problem domain. For that, and these are all different components required: image sensors, specialized image processing hardware, hard copy, image processing software, mass storage, computer, image displays, and then the system is connected to network. I'll explain each component. First is, see here, the first is image sensors. Image sensor is used to sense the image. Actually, to acquire a digital image, we need two things. The first is physical sensor and the second is a digitizer. This physical sensor responds to the energy radiated by the object we wish to image. See, whenever a light focused on the image, then it gives reflection. That reflected light is collected by the physical sensor, and then that signal is given to the digitizer, is a device for converting the output of the physical sensing device into the digital form. Okay, so in this way you can acquire the image. The next block is specialized image processing hardware. This specialized image processing hardware mainly consists of the digitizer, which will convert the data sensed by the physical sensor into digital form. Along with that, it has arithmetic logic unit that performs arithmetic and logical operations in parallel to entire images. Also called a front-end subsystem, and its most distinguished characteristic is speed. Specialized image processing hardware is having higher speed. This specialized image processing hardware can do the operations in a very faster way. With a normal computer, handle the functions which requires high speed or fast data throughputs. Next is computer. Is a general purpose computer and can range from a PC to a supercomputer. In detailed applications, sometimes specially designed computers are used to achieve a required level of performance. The next one is software. We need a specialized software to do some specific task on image. A well-designed package also includes the capability for the user to write the code. As a minimum, utilizes special modules. See, to do specific operations on the image, we need a well-designed package, is with which the user can write the code to do the operations on the image. In general, for image processing tasks, image processing toolbox of the MATLAB is used. It's a very common and a well-equipped image processing system. Not only with the MATLAB, nowadays we are doing the same operations even with Python also, but it is the most efficient thing. We know that images requires large amount of storage space, hence mass storage capacity is very important in image processing applications. For example, if you take an image of size 1024 by 1024 pixels, in which the intensity of each pixel is of 8-bit quantity, the total image size is 1 megabyte if it is not compressed. What is 1 by 1 megabyte? 1 megabyte means 10 power 6 bytes. So imagine how much amount of storage space is required to store one image. See, if one image occupies this much amount of space, then imagine if you are handling many images, how much amount of space is required. Okay, that is the reason mass storage capacity is very important in image processing applications. This storage is divided into three principal categories: short-term storage for use during processing, and online storage for relatively fast recall, and archival storage characterized by infrequent access. Okay, I think you understand all these three terms. During the process, we need short-term storage. Fast recall, there is online storage, and for storing, we have archival storage. This archival storage is used when there is infrequent access. Okay. Then storage is measured in bytes. See, you know it already. Bytes means 8 bits. Kilobytes 10 power 3 bytes. Megabytes 10 power 6 bytes. Gigabytes 10 power 9 bytes. And terabytes 10 power 12 bytes. So these are all different mass storage devices. Hard disk, then RAID server, desktop PCs, laptops and Macs, CD or DVD, digital devices, memory sticks, floppy disks, smart media and tape media. Next is image displays. The displays used today are mainly color and flat screen monitors. Okay. Yes, monitors are driven by the outputs of the image and graphics display cards that are an integral part of the computer system. The next is hard copy. If we want to take a hard copy of an image, what we need? We need hard copy giving devices. What are those devices? Those devices are laser printers, film cameras, heat sensitive devices, inkjet units and digital units such as optical and CD-ROM disks. Okay, so these are the hard copy devices in computer. Okay, printers, scanners, Xerox machines. Film provides the highest possible resolution, but paper is the obvious medium of choice for written material. Okay. For presentations of the images are displayed on the films or walls by using projectors. And the last one is networking. Okay, to process an image, we need all these components, and all these components are connected with a network. And if you want to send our processed image to another place also, we need networks. Okay, you're sending images and images occupies large amount of data. Here for transmitting the images, the main consideration is bandwidth. Yes, we must have high bandwidth to send the images through internet. No problem, we'll have optical fibers and other broadband technologies which will provide highest bandwidth for the transmission of images. Image data compression continues to play a major role in the transmission of large amounts of image data. What is the need of image compression? As the image occupies a lot of space, to transmit it as it is, we need a lot of bandwidth. So if you compress the image, then automatically it will occupy less space, so that we can transmit that using less bandwidth. Okay. So that is the main point here in the networking concepts. Okay. Yes, these are all the components of image processing system. Okay. Yes, I'll summarize. First, the problem domain means what type of image processing techniques that you're going to perform on the given image. Yes, to get that image, first you need image sensor which will capture the image. Okay, and then it is given to the specialized image processing hardware which will do some logical and also arithmetic operations. Okay, then we need a computer to process this image. Okay, to process that image, we need an image processing software like MATLAB. Okay, and then to store that image or processed image, we need mass storage. And here the mass storage is of very high capacity. And then after the processing, if you want to display that image, use some monitors, or if you want to take a printout, or if you want to take a hard copy of the image, you need hard copy devices like printers, scanners and Xerox machines like that. Okay, and all these things are connected to the network, and network is also used to transmit our processed image. Yes, for the transmission, we need a lot of bandwidth because image occupies a lot of space. But with the optical fiber and with some broadband technologies, we had high amount of transmission bandwidth through which we can send our processed image. Even with the image compression, you can decrease the size occupied by the image so that we can transmit that compressed image in less bandwidth. Okay, so this is about the components of image processing system. Thank you very much.
Thank you for watching this video. If you like this video, please don't forget to like, share and subscribe.